Welcome to this comprehensive guide for beginners on dynamically adding and removing C# scripts, also known as components, to game objects in a game engine. We'll focus on practical examples within Unity, starting with the foundational concepts of game objects and components. Game objects are the fundamental building blocks of a Unity scene, representing everything from characters to scenery. A game object itself is a container, gaining functionality through attached components. Every game object inherently includes a transform component, dictating its position, rotation, and scale in the game world. Components are the functional parts of a game object, defining its behavior, and are essentially C# scripts inheriting from monobehavior. Examples include built-in components like light or camera, as well as your custom scripts. Now, let's explore how to add components dynamically using C# code. The addComponentT method is crucial for adding a component or script to a game object at runtime. The T specifies the type of component to add, such as Box Collider, allowing you to change object behavior on the fly. You can also add scripts by passing the name of the script class directly. Before adding a component, it's good practice to check if it already exists to prevent errors. This can be achieved using try_getComponentT or getComponentT. Try_getComponentT attempts to retrieve the component and returns true if it exists, storing the component in an out parameter. GetComponentT returns the component if found and null otherwise. Here's a code example. First, we check if a Box Collider component already exists on the game object. If it doesn't exist, we then add the Box Collider to the game object. Some components require others to function. addComponentT automatically adds these required components. For instance, adding a hinge joint will automatically add a rigid body as well. Next, let's look at how to remove components dynamically. The destroy method is used to remove a component from a game object, scheduling it for destruction at the end of the current frame. This ensures the object can still be used during the current update loop without causing reference errors. In contrast, destroy immediate immediately destroys the component. It's generally recommended to avoid destroy immediate unless necessary, as it can cause instability if other parts of the code still reference the component. Destroy immediate is primarily useful in edit mode when creating tools. Here's a code example for removing a component. First, we get the Box Collider component. Then, if it exists, we schedule it for destruction using destroy_bc. When destroying components, especially during runtime, always consider potential dependencies to avoid unexpected behavior. Let's review some best practices and additional tips for working with components. Minimize runtime changes to components whenever possible, as adding or removing them can impact performance. It's generally better to configure components in the editor for optimal performance. Always check for null references before accessing a component's properties or methods to avoid null reference exception errors. For complex configurations, consider using scriptable objects to manage component settings. Optimize component usage by avoiding the attachment of unnecessary components to game objects, which improves performance. Instead of destroying a component, you can disable it by setting its enabled property to false. This preserves the component's values if you need to re-enable it later. Finally, let's quickly review how to manage components directly in the Unity editor. To add a component in the Unity editor, select a game object, click Add Component in the inspector, and choose the desired component. To remove a component, select the game object, locate the component in the inspector, right-click its header, and select Remove Component. Understanding dynamic component management is a powerful skill for any C# game developer. Keep practicing these techniques to build more flexible and robust game systems.